All right, so for question number 2, we have to find g prime of 0 and g double prime of 0. Okay, so we have this relationship right here. So how can we compute g prime of 0 and g double prime of 0? If the antiderivative of f is g, then what's the relationship between g and f? If you integrate f to get g, then if you differentiate g, you're simply going to get f. Okay? So let's go ahead and write down some equations to help us solve number 2. We know that g of x is the integral from -3 to x of f of t dt. So what we're going to do here is we're going to use the fundamental theorem of calculus part 1 to determine what f of to determine what the derivative g prime of x is, okay? So what happens if you differentiate this function? If you find d dx of g of x, well, you have to find the derivative of the right side, which is an integral, right? You don't have to do this. I'm just showing you the steps to arrive at the conclusion I'm about to show you. So from -3 to x of f of t dt. So you're going to find that the derivative of that. So using FTC part 1, remember what you do, you just basically, this derivative cancels with an integral, and you plug in this variable into your function, and you multiply the function by the derivative of your upper limit, which is going to be 1. So this is simply going to be f of x. Okay? All right, so g prime of x is equal to f of x. Okay? Because g is the antiderivative of f, so f is going to be, the derivative of g is going to be f, or f is the derivative of g. Okay, so if g prime of x is equal to f of x, that implies that g prime of 0 is going to be f of 0. Okay? So what is f of 0? Is the output you get when you plug in 0 into this graph that we have here. So if you evaluate this function at x equals 0, your output is going to be -3. Okay? So what we have, f of 0 is equal to -3. So there you have it. Now note that in this problem you're given the graph of f. Okay? So since f is the antiderivative of g, then f is simply going to be g prime. Okay, so this graph that you're given is f is also g prime because the integral of f is equal to g. So these two are basically the same thing here. That's what we have stated here. G prime is equal to f. So this graph is also the graph of g prime. Okay, now the second part we're to find is g double prime. Now, if we have, if g prime of x is equal to f, then g double prime of x is simply going to be what? It's simply going to be the derivative of this function right here. It's going to be f prime of x. Okay? So if g double prime of x is equal to f prime of x, then what is g double prime of 0 going to be? G double prime of 0 is simply going to be f prime of 0. Okay? F prime of 0 just means that we are computing the slope of a tangent line at x equals 0. So what's the slope of a tangent line here? What kind of tangent line do we have at x equals 0? We have a horizontal tangent line. Okay? So what is the slope of a horizontal line? The slope of a horizontal line is 0. So f prime, show it to you again, slope of this line is 0. So f prime, which is the same thing as g double prime, is equal to 0. Okay? So those are the two answers for question number 2. All right, let's shift our attention to number 3. I made a slight adjustment here. We are to find all the points where G has a horizontal tangent line. Okay? All the points where G has an horizontal tangent line. So remember, what graph is this? This is a graph of f, which is equal to g prime. Okay? So we're not looking at the points where we have a horizontal tangent to this curve, because this curve is a derivative of g. So when do we have a horizontal tangent? We have a horizontal tangent when g prime is equal to 0. Okay, so let's go ahead and write that down. Let me divvy up my workspace here so I can work it in such a way where you can see the graph. So for part 3, we have, or let's say G has a tangent line, a horizontal tangent. G has a horizontal tangent line when its derivative is instantaneous rate of change, g prime of x is equal to 0. Okay, so since g prime of x is equal to f of x, g has a tangent line when g has a horizontal tangent, horizontal tangent where when f of x is equal to 0. So all we're looking for is where this graph is equal to 0 in the interior. Okay, so we're not including the endpoints. Okay, so in this interior, where is this function? This is a graph of the derivative of g, which is known as f. Where is it equal to 0? It's equal to 0 at 2 points, right here and right here. So the zeros of f tell you the points where the derivative is 0, which means that you have a horizontal tangent line. Okay, so at 3 and -3, those are the x values where you have horizontal tangent lines. So at x equals -3 and x equals 3, leave out my workspace, make it a little bit longer so we don't get confused. So at these 2 points, f of x, which is equal to g prime of x, is equal to 0, and then that's the answer. Okay, and then this means, which means that G has horizontal tangent lines, here. Okay, so I'm just writing all this just in case you're asked to justify your answers when you're answering the question. Now let's move on to the lesson.